Good day, students. So in this clip, we're going to be going over some questions to get you ready for the test that's coming up. So I just want to commend you for taking the time to go over this presentation. Hopefully, you get the grade that you deserve on the test, okay? All right, let's take a look at question number one. It says, graph the function. The function we're looking at is f of x equals negative 2x squared plus 6x plus 2. Now, since it is a multiple choice question, we can take advantage of the options and eliminate improbable answers just based on the look of our answer of the question. Okay? So if you take a look at the question, we have A is negative 2, and that gives us some very important information about the graph. Since A is negative, that tells you that the parabola opens downwards, it's like a south parabola, and we have a maximum. So since A is negative, that automatically tells me that B and D cannot be answers since these are parabolas with A that's with a positive value. Okay? So the answer is either A or C. So now there are two ways we can solve this problem. First, we can either change this into vertex or transformational form and find the vertex, or we can find the coordinate of the vertex, the x coordinate of the vertex. Since this has a negative x coordinate and this has a positive x coordinate, the quickest way to solve this would be just to use x equals negative b over 2a to find the x coordinate of our vertex. Okay? So a is negative 2, b is 6. So we're going to plug in these two. So x is going to be negative 6 divided by 2 times negative 2, which is negative 6 over negative 4. And if you divide that out, it reduces to 3 over 2, which equals 1.5. All right? And that's a positive number, so 1.5 here corresponds to the x coordinate of a vertex. So our answer is option C. All right? Okay, moving along. Let's take a look at number 3. It says find f plus g of x for the following functions. So what does f plus g of x mean? F plus g of x simply means f of x plus g of x. Okay? So let's go ahead and compute that. So f of x is 4x squared plus x plus 3. And then I'll just line up g of x right under there, making sure that terms with like degrees are in the same column. Okay, so we line it up like that, and I'll just add downwards. Okay, so if I add downwards, I'll have 4x squared plus this. There's a 1 here, right? So 1 plus 5 is 6, with 6x plus 7. So our answer is option C. All right, now let's move on to question number 5. It says, what is f minus g of x? F minus g of x is a shorthand way of writing f of x minus g of x. Okay, so let's work this out. So f of x is 11x plus 20, and then let me write it down here because I might need some space. So 11x plus 20 is f of x, and then g of x is negative 15x squared plus 6x plus 27. We're subtracting, so we're going to have a minus parentheses here. Okay? So what am I going to do with that? Well, anytime you're subtracting, you have to distribute the negative to what you're subtracting from the other. Okay? So minus will be distributed to all the g's. So I'm going to distribute minus to all these terms right here. So that's going to become, we'll leave the top alone, 11x plus 20. And then the bottom becomes 15x squared, because minus times minus is a plus, minus 6x minus 27. Okay? And then we're going to add downwards. And then when we combine downwards, our answer is going to be 15x squared plus 5x minus 7. Okay? So there you have it. All right, so let's see which one matches with this. The answer is option A. All right, let's move on to question number 7. What is f times g of x? Well, f times g of x just simply means we're going to multiply f of x by g of x, okay? To keep our terms organized, it's good to just do multiply vertically, so that's what I'm going to do, okay? So we have 2x squared minus 7x minus 6. We're going to multiply that by 13x minus 9. All right? Okay, so let's go ahead and multiply. I'm going to distribute the 0 degree term to everything on the in F, and then we'll advance to the 1 degree term of G and distribute to everything in F. All right, so let's start with negative 9 times 6. Negative 9 times 6 is positive 54. Negative 9 times 7 is positive 63. Positive 63x. Negative 9 times 2 is negative 18x squared. Okay, so just distribute 9 to all of them. Now 13 times 6 is, we have 60 plus 18, 78x, negative 78x, and then 13 times 7 is negative 91x squared, and then 13 times 2 is 26 x to the third. Okay, so you see how doing it vertically has everything nicely organized. So I'll just add downwards, and that should give me my answer. All right, so adding downwards, 54 just drops down, 54, and if I add this 2, just correct it's going to be negative 15x, and then these two add up to 109, negative 109x squared, and then just bring down 26x to the third. So your final answer is option letter A. Okay, so the answer is option A. All right, now let's move on to question number 9. This one involves finding the quotient. So it says, what is f over g of x? So if you look at the options, you notice that no factorization was done. So we know that the numerator, so we know that f over g of x is simply f of x over g of x. F of x is 22x to the third minus 9x squared plus 11x minus 5. And that whole thing divided by negative 13x squared minus 1. There's a constraint which is as to the denominator. Remember, you cannot divide by 0. So what you do is you set the denominator equal to 0 and solve. So the denominator is, I'll do this in green, is negative 13x squared minus 1. That cannot be 0. If it were, it's going to be undefined. So this value has to be excluded from the domain. Okay, so whatever x value that makes this happen. So let's go ahead and solve this. Add 1 to both sides. We have negative 13x squared equals 1. Divide both sides by negative 13. And then you notice that x squared cannot be negative 1 over 13. So let's see which one matches with that. So our answer is this quotient, and x squared cannot be negative 1 over 13. So the answer is option letter B. Okay, you gotta be real careful with the domain. All right, domain restriction. All right, moving along to question 11. So these graphs, one of these graphs represents the solution, not only the graph but also the description of the location of the solution. So let's take a look at this equation right here. Which of these can not be possible matches for this graph? Well, if you take a look at A, you notice that A is negative. So if A is negative, that means that you have a sad situation, just like the first example we did. So these ones opening up are automatically eliminated. All right, so these two graphs are identical, so the only thing that distinguishes them is the description of where the roots are. This one says one solution is between 0 and negative 1. 0 and negative 1, that's right, while the other is between 2 and 3. That's right. And if you take a look at this, it says one is between 2 and negative 1. Absolutely wrong. There is one between 2 and negative 1. It's too wide. It's supposed to be between 2 and 3. Okay? So the correct answer is A, based on the fact that the location of the zeros or the solutions were correctly described here. Okay, one is between negative 1 and 0, and the other is between 2 and 3. Okay, so there goes the first 0, or solution, and there goes the second solution. So the answer is A. Okay, let's move on to question number 13. We're given a quadratic in standard form, and we have to find the equation of the axis of symmetry and the y-intercept. So remember, C is your y-intercept. So if you take a look at its function, f of x equals negative 2x squared minus 2x plus 2. The y-intercept C is the y-intercept, so C is 2. So if you take a look at all these options right here, you can see that option D cannot be answered because it says y-intercept is negative 2. Option B cannot be an answer because it says y-intercept is 1/2. And option A cannot be an answer either, so by elimination, the answer is C. Okay? If you wanted to look for the axis of symmetry, the equation of the axis of symmetry, you're going to use x equals negative b over 2a, because the x-coordinate of the vertex is your axis of symmetry. So in this problem, a is negative 2, and b is equal to negative 2. So we'll solve that. We're going to have negative 2 over 2 times negative 2. When we work this out, we'll have 2 over negative 4, which is negative 1/2. This is the axis of symmetry. This is not the x-intercept. So x equals negative 1/2 is your axis of symmetry. Okay? So had you got these two confused, you would have picked the wrong answer. So that you can clearly see that the axis of symmetry is x equals negative 2, and the y-intercept is 2. That makes our answer C. Alright? Okay, let's move on to question 15. It's asking about the maximum and the value, maximum or minimum and the value. So we're going to take a look at A and the orientation of the graph, and then to narrow down our options, then we'll go ahead and find the maximum or the minimum value. Okay? So if you take a look at this quadratic, f of x equals x squared minus 8x plus 2. We can clearly see that A is 1, which is positive. So we're going to have a happy parabola. And the extrema is going to be a minimum. Okay? So that automatically eliminates C and D, because those are talking about maximum. So our answer is either A or B. Now let's find the value. So to find the value, all we have to do is we need to find the x-coordinate and then plug it into the original function. Okay? So basically, we need to do f of negative b over 2a. This is the minimum. So the mean is f of negative b over 2a. What does this mean? Find the x-coordinates of your vertex and then plug it back into the original problem. Alright? So let's find the x-coordinates of the vertex first. So that's going to be negative b. B in this problem is negative 8. So we're going to have negative 8 over 2a, 2 times 1. And it reduces into 8, negative 8 over 2, which equals negative 4. Okay? Am I done? Absolutely not. I need to plug it back into the original problem. So f of negative b over 2a is f of negative 4, which is negative 4 squared minus 8 times negative 4 plus 2. Alright, negative 4 squared is 16, minus 4 times minus 8 is positive 32 plus 2. So we're going to have 16 plus 34, which is equal to 50. So this is our minimum value. So the minimum is 50. Alright, so the answer is option B. Alright, now let's move along. Hold on. Alright, so let's take a look at this real quick. It looks like I messed up the sign. So the answer is not B, sorry about that. It's negative, so basically, we have negative B here, so there's supposed to be a negative over here. So negative, so B is negative 8. So that makes this a positive. So the x-coordinate of the vertex is actually positive 4. So it's supposed to plug in positive 4, so make that a plus, make that a plus. So you gotta be careful with the sign, or else you fall into a trap, like I just did. So, so you change that sign. So you're gonna have 16 minus 32 plus 2. Okay, this was supposed to be a positive. So that becomes negative 16 plus 2, which equals negative 14. Yeah, so the answer is supposed to be A. Sorry about that. Okay? Alright, so when you're doing negative b over 2a, don't forget your sign, or else you're gonna flip the whole vertex. Okay? So there you have it. Now let's move on to question number 17. It says which of this is a solution set? So let's go ahead and solve this first, and then we can see which one is the correct option. Alright, so we have negative x squared plus 2x equals 0. So I don't need to use the x game here because we have a binomial. So what I can do is I can break it down. Negative x times x plus 2 times x. What can I factor out of here? I can factor out an x and an x, right? And then we can factor out the negative x, or we can just factor out x. It doesn't make any difference. So let's factor out a negative x in this case. If I take out negative x, I'll be left with x minus 2 equals x minus 2 equals 0. Okay? Now we're going to use the zero product property. Notice whenever we factor out a minus, the center sign changes. Okay? So using the zero product property, we have negative x equals 0, or x minus 2 equals 0. Alright, if you divide this by negative 1, you have x equals 0. And then this one just add 2, and you have x equals 2. So your solutions are going to be 0 and 2. Answer is option letter B. Okay? Alright, now let's move on to question 19. Question 19 is similar to question 17. We have negative 2x squared minus 2x equals 0. So we can break this down. Negative 2 times x minus 2 times x. And then what can I factor out? I can factor out negative 2 because they're common to both terms. So factor out a negative and then also an x. So negative 2x can come out. So we're going to have negative 2x on the outside. And then you're going to be left with x. So you take out a negative, this becomes a plus, x plus 1. Anytime you take out everything, you're going to be left with a 1, okay? Equals 0. Now using the zero product property, you have negative 2x equals 0, or x plus 1 equals 0. Alright? So to finish this one off, on the left side, divide by negative 2, both of them. So you're going to have x equals 0. And then this one, you just subtract 1 from both sides. And you have x equals negative 1. So your solution set is negative 1 and 0. Alright? Which is option letter C. Okay, moving right along. Alright, so in 21, we are supposed to generate a quadratic equation that has the solutions negative 8 and 3. So basically, I know that x is going to be equal to negative 8, and x is going to be equal to negative 3. So I'm going to use the reverse of the zero product property and also distribution to find the original problem that has these roots. So to make these two equal to 0, I just do the opposite. I add 8 to both sides. On this one and this one, just add 3, you do the opposite. So that I have both of them equal to 0. So I have x minus 8 equals 0, and x plus 3 equals 0. So I can state with confidence that x minus 8 times x plus 3 are equal to 0, the product, okay? So now I'm going to distribute this. X times x is x squared. X times 3 is plus 3x. And negative 8 times x is negative 8x. And negative 8 times 3 is negative 24. And then, wait a minute. Oh, I'm supposed to add it. I'm supposed to add it, so this was a plus. It's supposed to be a plus. This is a plus. This is a plus. Sorry about that. So it's x plus 8 and x plus 3. Okay, so you distribute it like that. And then we just add downwards. So we add downwards, we're going to have x squared plus 11x plus 24 equals 0 as the quadratic equation with negative 8 and 3 as its roots. Okay? So there you have it. This is the quickest way. There are other ways of doing it, but distributing using this algorithm is the quickest way. All right, let's move along to question 23. Similar procedure. We have two roots and we're supposed to find the quadratic equation that has those as roots. So we have x equals -9 and x equals 1. So for this one, I just add 9 to both sides. So I have x plus 9 equals 0. In this one, subtract 1, I have x minus 1 equals 0. And now you're going to multiply x plus 9 times x minus 1 equals 0. Alright, now we're going to distribute it out. X times x is x squared. X times 1 is negative x. 9 times x is positive 9x. And then 9 times 1 is negative 9. Okay, so we add downwards. So we're going to have x squared plus 8x minus 9 equals 0. And that's our final answer, which is option D. Okay? Alright, let's move on to, well, actually, I think I'm going to backtrack a little bit. Let me see. There's no need for that. All right, let's move on to option 25. Option 25 involves operation on complex numbers. So let's take a look at that. So for that, we're supposed to simplify the expression 10 minus 11i divided by 14 minus 15i. Okay? So to do this, we need to multiply the numerator and the denominator by the complex conjugate. This is what you get by inverting the sign of the denominator. So you times the top by 14 plus 15i, and then 14 minus plus 15i. How did you get that? You just switch the sign in the middle, okay? And then we're just going to distribute the top and the bottom. So if we distribute the top, we're going to have 10 times 14 is 140. 10 times 15 is plus 150i. And then 14 times 11, 14 is 154. So negative 154i. And then 15 times 11 is going to be negative 165 I squared. Okay, that's for the numerator. And then for the denominator, we're going to distribute same as we did on the top, same process. So 14 times 14 is 196, and then 14 times 15. 14 times 15 is going to be positive 210i. And then negative 15 times 14 is going to be negative 210i. And then 15 times 15 is going to be positive, actually negative 225i squared. Okay, negative 225i squared. Okay, now let's simplify this further. On the numerator, we're going to have 140 plus, actually, since the bigger number is negative, if I combine these two constants, it's going to be minus 4i. And then I squared is negative 1. If you times it by that, it becomes plus 165. And then divided by, in the denominator, I have 196. These two are opposite, so they cancel out. And then I squared is negative 1 times this is positive 225. Okay? Alright, now, so just remember that I squared is negative 1 and it changes the sign. Simplifying further, we're going to have 140 plus 165 as 200, actually it's 305, 305 minus 4i. If you add up the denominators, 196 plus 225, 1 carry 1, 421. You're going to end up with 421. And if you break them apart, you're going to have 305 over 421 minus 4 over 421i. Your final answer is option A. Okay? All right, now let's move on to question number 27. We're given an equation in standard form, and we're asked to express it in vertex form. So in this case, we have to use the completing the square algorithm to do this. So to do this, I have to create an incomplete square on the right side. So to do that, first I'm going to add 3 to both sides so I can have an incomplete square and then complete it. So we have y plus 3 equals x squared plus 2x. Okay? Now to complete the square, I need to add b over 2 squared to this side right here. I know that b is 2. So to make a perfect square trinomial, I divide it by 2. B over 2 equals 1. And when I square it, I get 1. So I'm going to add 1 to the left side. But to preserve equality, whatever I add to the left side, I need to add on to the right side, or else I've changed the equation. Okay? So since I'm adding 1 here to complete the square, to make a perfect square trinomial or complete square, I also have to add 1 here to preserve equality. Okay? So y plus 3 plus 1 is y plus 4 equals, now I can factor this, and this is a perfect square trinomial. I can use a factoring trick. You take the square root of the first and the last, bring down the middle sign, and that's, you're going to be left with x plus 1 quantity squared. Okay? Now this is a transformational form. In order to express this in vertex form, you're going to just subtract 4 from both sides, and then you have y equals x plus 1 quantity squared minus 4. Okay? Alright, so let's take a look at this. Also, the axis of symmetry, the equation of the axis of symmetry is the x-coordinate of the vertex, right? So the vertex in this case is going to be -1, and then the opposite of the number next to y is 4, -1, -4. So the axis of symmetry is the x-coordinate, right? So x equals -1 is the axis of symmetry. Okay. Alright, so let's see which one matches with what we have. Let me box my answer so you don't get confused. So there goes the answer right there. So let's look at equations first. Option A can be eliminated because the sign next to the x is inaccurate, so this is wrong. So it's either B, C, or D. Alright, so this one has the wrong axis of symmetry. It's actually referring to the y, which is the value of the maximum. Yeah, the maximum value. This one is x equals -1, which is exactly what we want, so the answer is C. What is wrong with this one? This one has a wrong C value right here. It's supposed to be -4. Okay, so this is also wrong. So the answer is option C. Alright, moving right along. Let's take a look at question 29. We are supposed to use a discriminant to describe the nature of the roots. So make sure that equation is in standard form. It already is in standard form. So to do this, what we're going to do is use the formula for the discriminant, which is b squared minus 4ac. So in this case, b is -20, a is -4, and c is +2. So the discriminant is going to be b squared, which is -20 squared, minus 4 times -4 times 2. If you work that out, you have 400 plus 4 times 4 is 16, times 2 is 32. If you combine the whole thing, you have 432. So this discriminant is greater than 0, right? So if it's greater than 0, we have two distinct real roots. Okay, if it were negative, it would be imaginary. Two distinct real roots. Okay? And then since 432 is not a perfect square, they're going to be irrational. Okay, how did I know that is not a perfect square? Because when you take the square root of 432, you do not get an integer. So square root of 432 is a non-integer, so it's not a perfect square, so it's going to be irrational. All right, so the correct answer is going to be option B. The discriminant is 432. Is greater than 0 and not a perfect square, so we have two distinct real roots that are irrational. Okay? Alright. Now we are also going to take a look at question number 30. Let's solve. So to solve that, we have the equation 5x minus 2 squared equals 110. This is like a halfway procedure for the completing the square algorithm. So I'll just get rid of the square, the 2, and then the 5. Okay, so to get rid of the square, I'll use the opposite of a square, which is square root. So I'll read the left side and the right side. So I'll have on the left side the absolute value of 5x minus 2 equals the square root of 110. Can 110 be reduced? Let's see, take out 2. 2 goes there, 5, 55, take out 5, 11. So no factors repeat, so nothing can break out of the square root. So we'll leave it just like that. Now absolute value is distance from 0 to the left or to the right, so it's going to be replaced with plus or minus 5x minus 2 equals root 110. Alright, I'm going to divide both sides by plus or minus 1 to move the sign to the other side, so plus or minus 1. And then plus or minus 1, that's a 1 there, not an I, let me fix that. So divide both sides by plus or minus 1. And we're going to have 5x minus 2 equals plus or minus the square root of 110. Let me look at how they express the answers. They broke them apart. Okay. So now what we're going to do is we're going to add 2 to both sides. So we're going to have 5x equals 2 plus or minus root 110. And then let me finish my work on the upper left corner so we can have a glimpse at the answer. So moving it up over here, we're going to divide both sides by 5. Divide this by 5 and divide that by 5. So that's going to give us x equals 2 plus or minus the square root of 110 over 5. And if we write them as 2 separate roots, our answers will be squiggly bracket 2 minus root 110 over 5, comma 2 plus root 110 over 5. Okay, so our answer is option D. Okay, let's move on to question number 31. I asked for the absolute value of the complex number. So the absolute value of the complex number, remember what we did before. We talked about absolute value being the z, and we can find that just by using the Pythagorean Theorem, okay? So we have we have z equals 2 plus 3r. And then the formula for the magnitude of z is equal to the square root of a squared plus b squared. Okay, so that's how you find it. So you can look at this as c and a b. Okay, so if you remember the Pythagorean theorem, is c squared equals a squared plus b squared, right? And then the c is equal to the square root of a squared plus b squared. All right, so you can write this as z squared equals a squared plus b squared. So z squared is what we're looking for. A squared is going to be 2 squared plus b squared is going to be 3 squared. Remember, you never take the I. Remember, for complex numbers, a plus bi, b is the coefficient of the I, not. So don't take the I with it, all right? Or else you ruin your answer. So if you have this, you can have z squared equals 4 plus 9. And then z squared equals 13. Don't forget to root it, so we're going to root both sides. So the norm, or the absolute value, equals the square root of 13. Okay? And we can work that out, simplify that with a calculator. What is the square root of 13? It's 3.6, or you can guesstimate and to figure out that is between 3 and 4, right? So this one is approximately 3.61, and that's your final answer. Okay? Alright. Alright, let's take a look at question number 33. It says sketch the graph of this. The quadratic function is in transformational form. If we can find the vertex, I think it'll be easy for us to determine what the accurate graph is, okay? So the vertex for this, you take the opposite of the number next to the x, which is negative 3, and the opposite of the number next to the y, which is positive 2. So this value is in the third quadrants. So which of them has a vertex at negative 3 and 2? 1, 2, 3, 2. Actually, it's in the second quadrant. So you go to the left 3, right? So 1, 2, 3, negative 3, 2. This is your answer. The answer is option C. Okay? So just by using the vertex here, you can find the graph because they're all identical. They just shifted in different directions. Okay? So remember, this is 3 units to the left and up 2 units. All right. Now let's move on to question 35. We're asked to find the inverse of this function. So to find the inverse, I can rewrite this as y. Remember, f of x is y equals x minus 1/4. So first thing I'll do is I'll switch my x's and my y. So I have x equals y minus 1/4. And I'll solve for my new y, and that'll be my inverse. So I'll just add 1/4 to both sides. And then I'll have y equals x plus 1/4. And that will be my inverse. I think in this problem they're calling the inverse g of x. Doesn't really matter. So g of x is x plus 1/4. Your answer is option A. Okay. All right. So let's take a look at number 1 for the short answer, and that will be that. So let's find the inverse. So to find the inverse of a relation in ordered pair, all you simply do is you switch around the axis. You switch the x goes to the y goes to the x, the x goes to the y goes to the x, the x goes to the y goes to the x goes to the y. You invert them like that, so you're going to have -7, -2, -2, -7, and then -1, 0 as the ordered pair representing the inverse of this relation. Okay? So thanks so much for taking the time to watch this presentation. If you haven't already done so, you can feel free to subscribe to my channel. Just click right up here to subscribe, and you can share this with your friends via Facebook or Twitter. More videos on microserve.com. Thanks again, and have a wonderful day.